Yeah, my name's Jaron. I work for Jam Threat Labs, where we kind of look for new ways to detect malware in the wild and for our customers. And so today I'm going to be talking a bit about an older piece of malware, actually, that we looked to in the past and kind of did some research around and did a blog post of, all tied under the theme of cryptojacking. So really, this is like a sly piece of malware. It is not super advanced. Okay, so that's one of the things we actually like about it when pitching it, is it's kind of easy for other audiences to understand. It doesn't really matter how much experience you have in the space. There's still parts of it you can take away, even if you're not, a full-on reverse engineer or anything like that. So that's why we kind of like bringing this talk back up and walking through this, because in reality, this is not a super advanced piece of malware. It's very much a Frankenstein of a bunch of different technologies brought together. Yeah, we're going to be diving into some content here pretty quickly, just in terms of how cryptojacking works and how this malware kind of implemented its different tooling to go after users. So, like I said, this was a couple years ago. At this point, we actually got a fair bit of shouts out on this blog when we released it. So really, the story that I'm kind of revealing here today is just a behind the scenes of what we went through to kind of unveil everything that was going on that we couldn't really fit into the blog. So we did have quite a few people that picked this up and kind of ran with it. So that was fun. Let's first discuss, before we kind of get into this malware and what it was doing, let's talk about how crypto mining works, because that's actually very relevant to this malware. So the topic's fairly involved. The goal here is not to make you some type of blockchain expert when you leave. Maybe you already know a lot about blockchain, but by the end of this talk, we're hoping to just discuss some of the different mining and how cryptocurrency works. So if you're not familiar, when it comes to cryptocurrency and mining, there's multiple different types, right? You can mine Bitcoin, you can mine Ethereum, you can mine Litecoin, Dogecoin, whatever you want. The list is massive in terms of the different cryptocurrencies that are now available, right? So in the legitimate world of crypto mining, you volunteer your computer resources to kind of solve this complex math problem. So your computer is making calculations, hoping that it's going to be able to solve those math problems before other miners out there are able to solve them. If it's successful in doing so, a block gets added to the blockchain. So for each block you solve, you get rewarded in the currency of your choice that you are mining. So solving these blocks means the miner gets money and the blockchain gains a block. Everybody kind of wins, and that's kind of the whole concept of how the mining process works. However, it's not quite as simple as printing money, right? We all know kind of that one person that's like, yeah, I'm going to buy a rig and I'm going to make a ton of money mining Bitcoin, and it's like 2 years later and they've made a couple cents, right? There's a lot of overhead involved with mining. So, for example, as blocks are solved, the reward for solving a block goes down over time. That means over time you might spend additional money on hardware to mine more Bitcoin or whatever cryptocurrency you want. So it also means that those who get involved early in mining were rewarded far better than those that got involved late, not even taking the dollar amount of the dollar value of the cryptocurrency into account itself. So on top of that, there's additional expenses and overhead to kind of get into this world. There's, of course, the additional expense of computer hardware. Remember, the goal of mining crypto is to do it as fast as possible, which means having top-end hardware. In fact, today's common hardware to get into Bitcoin mining could run as much as 10K for like your initial entry-level Bitcoin miner that's going to do something for you. Then on top of this, there's, of course, massive electric bills, right? You're powering these giant calculating monsters to run at 100% all day and night. This takes a lot of power. Finally, of course, you have the fact that cryptocurrency works like an unpredictable stock market. So no one can ever quite tell if the value is going to go up or if it's going to go down. The risk, you always risk that chance that, you're going to rack up an electric bill, you're going to spend all this money on hardware, and of course, maybe the market's going to go down. You don't have that answer going into it, right? So knowing all that, Part of our team's threat hunting model, so we're kind of switching over to security here at the moment, involves monitoring threat detections that are kind of out there in the wild, right? So we can potentially identify malware that's being reused or modified in some sense. So one day, while viewing some of the alerts we go through and that we've written, we stumbled upon a threat prevention alert that captured our attention. And that was because of an open source mining program called XMRig is the rule that hit, that we discovered was hitting where we saw like someone mining cryptocurrency. To be clear, there's nothing malicious about XMRig, right? Anyone can use XMRig. It's free, it's open source, it's available to everyone. Anyone that wants to mine Bitcoin is welcome to use it. However, what was suspicious was the file path from which XMRig was seen on this system. And that's because the detection was hitting on the path to Final Cut Pro. If you're not familiar with Final Cut Pro, it's an application, written and released by Apple. You can buy it on the App Store for about $300. Now, Apple's stock was not doing so poorly that they would implement all kinds of, Bitcoin miners into Final Cut Pro. We know we weren't there. We know Apple's doing fine. We know they don't need to Bitcoin. They don't need to mine on every single computer, right? So we knew that looking at this, even just based on the site alone, this was probably a malicious scenario, and we decided to kind of dig a little further into it. So next, we kind of take the file hash associated with this alert. We have a number of different ways, as a lot of us do, for like looking for a malware sample. But we'll often start by taking a hash and just plugging it into, VirusTotal. That's kind of the easy way to go to know if this has been discovered before or not, or if it's made its way to kind of the wild. VirusTotal is a great indicator of that. However, what we discovered is that it was not on VirusTotal. So when something like this happens, we're left with a few options in terms of actually trying to go out and collect this sample. So instead, we decided to go out in search of where we could find this hash. It's fairly obvious that anything installed under the guise of Final Cut Pro stands a pretty high probability of being pirated software, right? So we took our search to one of the places we thought we'd be most likely to find it, the Pirate Bay. When we did a search for Final Cut Pro, we wanted to know if anyone was kind of hosting this. So we went ahead, kind of found one, downloaded the torrent really quick, and then just kind of dropped it into the applications directory and ran it. Now, if you've never seen something open before, this is about the last thing you want to see at the bottom of your screen. There's a bunch of terminals just kind of kick off and install. Now, as it turns out, Final Cut Pro does do a fair bit of that on its initial install, but I don't know if it does quite that much. So you notice that at the bottom of your screen, just a ton of stuff happened there as we ran Final Cut Pro for the first time, right? So we did notice that this Final Cut Pro, it seemed to check all the boxes in terms of what we would normally find in the legitimate application. The file paths all seemed aligned up, and the pirated app, this pirated app did appear to be mostly functional when we went to open it. It seemed like everything operated kind of as expected. But we kind of further confirmed our suspicions by looking at the main executable here within the app, and it was 11.9 megabytes. We happen to have other people running Final Cut Pro and legitimately, and we knew it was only 3.9 megabytes if you look at an actual copy installed by Apple. So the executable in this pirated version of the application seems significantly larger than the legitimate one, and this can be another sign that possibly malware was at play, right? Now, lastly, by far the most suspicious fact is we notice the hash of the pirated Final Cut Pro that matched the XMRig alert that we wrote also matched this sample exactly. So we knew that what we downloaded from the Pirate Bay was also what we had seen on the user's system that they had installed and run. And we know that ultimately this Final Cut Pro, somewhere embedded inside of that, is a crypto miner inside of that executable. So we kind of take that executable and, we like to get our hands dirty. We like to take a look at it, see what it's up to, see if there's any readable strings that maybe it contains within it. When you're dealing with a file that's 11.9 megabytes, you're going to find a lot of strings, most likely. So we kind of scroll through, we find the ones that are the most interesting. I know that's probably very difficult to read on your eyes, on the TV, as well as in general. That's a hideous bash script is what you're looking at. But it's embedded directly inside this executable. We'll get back to that a little bit later. If we continue to scroll up, we see there's an absolutely massive blob of data. This is actually where a good majority of the malware is hiding. So if you're not super familiar on the analysis side or haven't been in security super long, you probably easily recognize this as a base64 blob. Attackers often use base64 as a way to embed content within other content. So using this, we can kind of encode and decode data really easily. It's a very easy way for an attacker to take the bytes of an executable and encode them directly into another executable if they really want. So that's what we're actually looking at here. Someone has hidden an executable file within the Final Cut Pro executable, and the malware knows where to go and look in order to pull that out and run it. So here's what happens when the victim clicks on this Final Cut Pro application. First, of course, the main application executable runs. That's in the bundle. When it runs, it reaches into itself and it pulls out two large base64 blobs and it decodes them. The first blob is a working copy of Final Cut Pro. That's what it displays to the user so that they believe the app works as promised. The second base64 blob that gets decoded is that of yet another executable. After some additional research, we discovered it's actually a program called I2P, or AKA the Invisible Internet Protocol. If you haven't heard of this before, it basically operates as an alternative to Tor, and therefore kind of an alternative dark web, right? So here's the screenshot of kind of the Invisible Internet Protocol website. Definitely looks legitimate, right? Something you'd want on your company network. But users have the opportunity to download this and run it. Once again, like it's a free tool. So, but what does that mean? What happens when this daemon starts running on your computer? Basically, there are many users out there that want to remain anonymous, right, and run this same program. So they can all kind of agree, I will be part of this kind of this network, this anonymous network, and I will run your software so long as you keep me anonymous, right? And it basically causes your program, it causes your computer to act like a bit of a router. Its goal is to make it virtually impossible to trace back the communication between two systems. So to simplify this concept, imagine that each of these computers that's running the software is a house participating in a mail service, right? A little bit easier to think of it as that. The attacker's goal would be to use other participating houses in this neighborhood to get data from their house, we'll say in purple, over to the victim house, we'll say in green. So the way that I2P does this is by crafting a special message with layers of encryption. So envision it generating a random order of addresses before building a message inside of a message, inside of a message, so on and so forth. So when finished, we end up with this single envelope that contains multiple envelopes, each addressed accordingly. This message then gets sent to the most outer layer house that was chosen. We'll say, you know, the red house. That house will then take and kind of open the message and decrypt it using a key that only that specific house is aware of. That house then takes the next embedded message and passes it to the next house in line, where this is repeated over and over until it reaches its final destination, right? The victim, in this case, who has unknowingly signed up to join this neighborhood, the victim, this happens to them in the background when this malware runs. They are joined into this kind of anonymous network. This is how the attacker anonymously sends the minor configuration over to the victim without them knowing it. And it can't really be traced back to where that config came from. So this is what it looks like in our shady neighborhood, remember? Multiple houses are used to pass data from house to house randomly. And to make things even more complex, something that the Invisible Internet Protocol will do is it will pick a return tunnel that's completely different in terms of the response for the response communication. So again, completely anonymous and just kind of instant and happening in the background. Granted, you would experience more lag on the network than you would if you were just using normal communication, right? But for some people, that's considered worthwhile. Except, of course, we're not dealing with houses. We are dealing with various computers that have also installed this software. So, summary, basically using the invisible internet protocol, the victim reaches out to the attacker. The attacker then sends back the crypto mining configuration, remaining completely anonymous. The victim system now begins mining crypto on behalf of the attacker. So there's an additional detail about this configuration that we haven't covered yet, which is what the attacker has chosen to mine and why. Rather than mining Bitcoin or something more common on the victim system, they've actually specified in the config that they want to mine a currency called Monero. The question becomes, why? Why did they choose that? Well, Monero is designed to work really well on small CPUs, making the expensive entry level that we mentioned earlier kind of much cheaper. It boasts algorithms that are designed to kind of keep these massive Bitcoin generating monsters out of the game and make it so that any processor, like whatever the size of it be, can generate kind of at the same rate that maybe one of those monstrous computers could. So for this reason, laptops and Mac OS in general feed really nicely into this picture. Although there's nothing inherently evil or malicious about Monero, it's kind of hard to actually picture a use case that doesn't require a botnet to actually make money. So you can't argue it's malicious, but it is kind of like, how many computers you got set up doing this and how did you get them, right? So as we move forward through this presentation, just know that when mining Monero, the goal is to mine on as many consumer devices as possible rather than doing it on huge CPUs or a giant stacked computer. So just diving in even deeper here into the mining process, if you're not familiar, we mentioned earlier that crypto miners make money for solving blocks, right? That's how the whole process kind of works. So what we haven't really mentioned yet is that multiple computers can join together in the same pool to solve the same block. So picture every green gem here kind of as a group of computers trying to solve the same complex mathematical question. After solving a block, each computer that participated will receive a dividend payout for their participation. So it's kind of a way to break up these payouts. Instead of giving them to one thing, a group of people can come together to work and solve a pool. Then each pool of computers is given a new block to solve, and we just kind of repeat the process over and over as long as people are willing to partake. But notice that one of these pools, right, appears to be attacker controlled, and that's because this pool is filled with victims that have downloaded this pirated Final Cut Pro app, and actually many others that were on the internet as well. So each of these computers, of course, connects to the dark net using I2P. The attacker configuration then has each victim joining the same pool. That's part of the configuration that the attacker manages. This essentially creates that botnet of computers working together to solve the blocks. And keep in mind, since all of these are mining Monero, the number of victims becomes far more relevant than the computing power that's actually at play, right? So the attacker's hoping that over time, users will continue downloading this pirated software along with many others that they've infected, and the mining botnet will just continue to grow and grow, which means they can work together in these pools and own more of these pools in order to solve blocks quicker. So your computer does all the work to solve these problems, and the attacker gets an anonymous payout. That's really the one-line summary of everything that's happening here. From an Intel perspective, we knew where the malware was being hosted. So one thing we did was we kind of went back to the Pirate Bay and looked up the uploader, who in this case went by the username WTFizzat, followed by a very large number. We took a look at the other applications that the user had uploaded, and it turns out there's actually quite a few of them, from Final Cut Pro to Logic X to things like Adobe Photoshop, right? All pieces of software that have a fairly expensive entry level that someone who doesn't have that kind of money might want to get for free, right? And this is how they bring people in to that, by offering software that's there, but what you're paying in is a bunch of stuff happening in the background on your computer. This presumably, like going back and looking at this, kind of provided us with a history of this malware, right? Because we could see all the dates it was uploaded and stuff like that. So we actually noticed that its earliest samples were uploaded as far back as 2019. These early samples of the malware embedded a lot of different malicious executables inside of the application rather than acquiring them over the darknet. That whole darknet step kind of came in later on in further iterations of the malware. Here under the Mac OS folder, we can see that there's actually 3 hidden files. All of these were malicious. They were removed from later variants of the malware. In October 2019, the samples stopped including the hidden files and began acquiring them. That's when it started using the internet, the invisible internet protocol. Also interesting in what we would call Gen 1 was it would try to install as root on your system by prompting you for a password. That also phased out as the attacker realized they don't necessarily need root for any of these capabilities. So the first of these samples were uploaded to VirusTotal in 2020. So they'd been on the Pirate Bay for quite a while before they even made their way to VirusTotal. Old variants remained here in VirusTotal undetected, 0 hits. Then in 2020, a single vendor started kind of picking it up, and there was still. We went through kind of each of the pirated applications and discovered that a lot of them weren't being picked up by antivirus vendors. Later on in the year, there's a handful of vendors that started picking up various moving pieces, right? Like I said, this is kind of a Frankenstein piece of software, and various moving pieces were getting picked up. Some were getting hit by AV, but some were getting missed. Maybe some AV vendors started marking the invisible internet protocol as malware, while others, said, well, no, that's a legitimate tool. It's just kind of, it's a game of cat and mouse, and it just depends what those vendors decide on. So, later on in 2020, we see the malware removed persistence altogether. So there was a launch agent that was being used that would cause the crypto miner to run, but the attacker swaps this out in favor of the Final Cut Pro app being the persistence. In other words, they're just hoping as the user opens Final Cut Pro and uses it, that's when they're going to do all their mining. They've gotten rid of a launch agent or launch daemon and no longer, are no longer banking on that miner to be running 100% of the time. Hopefully, like, I guess the thought here might even be like the user opens a pirated Final Cut Pro, and that's when their computer runs hard because it's pirated. So why wouldn't it? There's nothing weird about that. So that brings us to the following year, which we kind of deemed Gen 2 samples of this malware. Gen 2 is still the same greater malware, but modified by the attacker to kind of evade antivirus after it started getting picked up by a handful of those vendors, even as far out as last year in 2023. So in July 2021 is when we saw another customer, or is when we saw customers getting hit by this, and we kind of started investigating it. Originally picked it up and started tracking it and kind of followed it through these different generations and just kind of watched the author to see what they were up to. And then finally we have what we call a Gen 3, which was uploaded to the Pirate Bay. Now, Gen 3 actually added a couple new stealth techniques, which we'll take a quick peek into, because these are really simple stealth techniques that, are very script kiddie-ish, but still effective in terms of the attacker's goals. So first off, we saw this large shell script embedded right inside the malware, right? If you recall, we actually, like I said, it's extremely painful to look at, even if you're kind of this bash guru. But if you take it and you add the line breaks in that you actually want, I know that's still hard to read with how far away you are, but we'll just pull out kind of the relevant portions of this, which are 2 kind of hacky but interesting techniques being used. The first is the line that you see here. Again, not overly performant on the attacker's end, but perhaps a bit creative. Let's break down this one-liner here, if you're not a bash script person. What we have going on is basically, this is going to say in a continuous loop, while Final Cut Pro is opened, we're going to check if the activity monitor is open, right? If the user opens activity monitor. If the user has opened activity monitor, we're going to kill the miner. and they won't see the miner inside of activity monitor. Otherwise, if activity monitor is closed, just keep mining at 100% CPU as fast as you can. That's essentially the steps here, kind of in this one-line bash script. So this is kind of an example. We kind of just, took the script logic itself and did it. And this is what you would see is just a script running, doing bad stuff, mining crypto. And then as soon as activity monitor opens, like the crypto miner goes down. That would not restart until the next time that you open Final Cut Pro. So the the author does seem to be like, yeah, if it's open, I'm mining. If I get caught, whatever. It's just kind of, it's an interesting approach. This brings us to the next kind of stealth technique used, and that's the command scene here. Now, this is a technique that's been seen in a fair bit of Linux malware, but to my knowledge, I hadn't seen this used much on the Mac OS side. So as many know, Mac OS is kind of this fusion of BSD Unix and the Mach microkernel, and is also POSIX compliant. So many things that work on BSD will end up working on Mac OS. So in this case, this command here will take a running process and it'll kind of change its arg0 value to match the name of an executable that's in the running process list. So essentially, what the author is doing here is saying, go find my crypto miner, and what I'm going to have you do is basically name it something, a process that's identical to other processes that are running on the system already. So meanwhile, the malware stays exactly like it's written. It just has a name that blends in much better. So that's all we're seeing there. You can essentially change, you can change that to anything you want. It doesn't have to be a running process. It can be anything you want. You can define it as the author. So the attacker, yeah, again, chooses MD worker local. This is chosen because you have a lot of MD worker processes running on your system. Oftentimes, attackers will choose this. Maybe if you find anything that's called MD this or that, and it's not signed by Apple, it's a good thing to look into. Pro tip. So yeah, the attacker knows this and tries to blend in through these methods. So just kind of quickly returning to the malware history timeline, this brings us down to May 2022, which is when we kind of saw the last Gen 2 sample uploaded to the Pirate Bay, right? This was going back and forth a lot. Like there were new versions of it, but the old versions were still like being hosted. It was an interesting scenario. So yeah, picking it up as XMRig happened somewhere in that window. And then we had seen some of the final changes get added like throughout this process. So hopefully you enjoyed that journey. Again, that's a lot of content kind of loaded into a shorter session, but when we share the research we've been looking at over the course of a few months, we like to kind of be thorough. So yeah, we like to kind of hope that kind of piques your interest into the world of Mac malware if you're kind of new to it. Yeah, we of course do a lot of research to protect against malware that's not just crypto miner related, right? But we feel this one tells a really good story, and it's kind of really easy to walk through in a fun game of cat and mouse. So that's what I have. Any questions or anything of the sort? Yeah, let me. Oh, thank you. Catchbox.
Okay, hello? Yes. Okay, so I thought it was interesting. I mean, I'm not sure if this is like safe to assume or not, but I thought it was interesting that a lot of the applications that the jacker was getting embedded into were hefty.
Mm-hmm.
So they're very like resource intensive applications like Final Cut, like Adobe, Logic Pro. So it seems like there was some sort of thought behind it to like, okay, like if this person is gonna like download this cracked software, they have the resources in that in their machine to actually like run the jacker like somewhat like without being detected or noticed in terms of performance.
It definitely could be. That could be tied. Yeah, sorry.
Yeah. So yeah, no, I was just gonna ask like if the if you mentioned that Monero is a little bit less resource intensive, right, than compared to like other currencies, but I was wondering if like you could actually notice the presence of the jacker in the machine if it's like just like running.
Like you as a user?
Yeah.
Yeah, definitely.
In terms of
Definitely. You
performance.
could see your computer slow way down. Some of that could also depend on, I believe, maybe the XMRig configuration. You probably can modify that to say like, here's how hard I want you to run versus like, let's remain a little stealthy, generate less, but have less of a chance of getting caught, right? But I don't believe we saw that. I believe we saw like it was just a full on. You open Final Cut Pro, you're at 100% CPU all of a sudden. I believe that's what we saw.
Okay.
But yeah, perhaps a assumption could be made that like it was put in safe software that might not stick out as suspicious because they are beefier software. It could also be, yeah, tied to just the fact that, again, I think these ones somewhere around $300 for a lot of those pieces of software, and there's more users out there that are willing to pay $1 to get an app versus 300, and maybe these make them good apps to target is because there's a lot of users out there that don't want to pay that full price, right? So it could be a combination of both, but yeah, this was just like run it 100% CPU, you're off to the races. Now with the M1s, you don't really have a fan anymore. With the Intel computers, like your fan would tip you off that this thing was going nuts, right? But like other than your computer kind of chugging along and you realizing it, you might have for some time with an M1, you might have not even really noticed that this was going on. So yeah,
Interesting.
yeah, I think you got a question behind you.
Thank you. To that point, does it run on the M1?
Yeah, I'm trying to remember. I believe most of them were compiled universal binaries. So they would run on M1 as well. I'm trying to remember if we saw any that were like installed Rosetta in the background in order to.
Yeah, typically you'd have like Rosetta already installed in the system, so it would probably run perfectly fine.
Yeah.
Probably be more if it was running
For
ARM. Yeah.
for how much of a Frankenstein it was surprising how like well it did actually work. Yeah. Yeah.
How much money did they actually like make? Because I don't know what that is equal to.
That's actually a really tough question to answer because that all comes down to how many victims there were. All we can really see is what's on Pirate Bay from like the Cedars perspective.
Yeah. Just like I'm thinking ballpark, like in the realm of, do we know?
No, it's impossible to kind of be able to guess that because
Interesting.
like all we would have insight into are the like our customers that got hit by it, which presumably are going to be more people on like a corporate network that hopefully aren't downloading this.
Yeah.
But yeah, based on the Cedars, I mean, we did do some rough numbers. I mean, and there were thousands of Cedars, and you can only see
That's crazy.
Cedars that are currently seeding,
But
right? So
I mean, like that cryptocurrency you're talking about, like what's that equal to in dollars? Like
anybody know the Monero?
No.
$50 or something.
That actually does sound
There
right.
was like thousands.
Yeah,
Okay.
it is volatile, but it's worth
Yeah,
something
yeah.
at this current moment, I think is the question. Yeah. Yeah, I think you're in the ballpark of 30 or 50.
You're good.
So that
It's not like 50 cents, so it's like a big cost when you start like.
But you do also, yeah, it's totally dependent on the number of computers that are mining for you.
Yeah,
which,
100%.
That's kind of the big part that is hard to calculate from the outside looking in. So
Yeah, good point.
How do you think I got out here? Yeah.
Did you do any attempt at attribution?
No, we kind of chalked this one up to cybercrime. A lot of cryptojacking. I mean, like it's certainly interesting, but you're not talking like, I mean, you're talking using someone's resources. So it's an interesting scenario, but it's kind of like we'll try to call you out. We'll try to get vendors to start picking up on you and hope that kind of fixes the problem.
I was wondering if North Korea might be involved.
Like with all the cryptocurrency theft that we've seen from North Korea, it's happening a lot, but we had no reason. I mean, this doesn't seem nearly stealthy enough to be something we would attribute to North Korea, but we didn't do a lot of follow-up on attribution or anything. So yeah, you got one over your left shoulder. Last question here.
A couple of questions, if that's okay.
Time for one.
Okay. I'm kind of curious if you looked at launch agents for Final Cut Pro after the
Like how they compare?
Since they removed the launch agent, the original launch agent. I don't know if that was actually the launch agent for Final Cut Pro or a different launch.
It
agent.
wasn't. I don't believe that.
Oh God, that's my fault. Mute.
Check, toast. Okay. I don't believe, I can't remember. It's been a while since we looked, but I don't believe Final Cut Pro actually requires a launch agent. I think by itself, when you open it, it might even, it updates through the App Store, I think. And I think There's nothing that opens it like by default at startup. So that launch agent kind of stuck out by itself. And it was pointed at a completely random file back when they were using the launch agent. So yeah, but we'll keep it moving along. If you got any other questions, feel free to find me after, and I'm down to talk more of this, definitely. So thank you.